In this example, we're going to evaluate this given limit. And because we're given the word evaluate in this problem, in this class you can assume that the limit exists if I ask you to evaluate it. So assuming the limit exists, let's find what it is. One of the first things you can notice is if you try plugging in 4 for x and 3 for y, you see right away in the denominator we're going to have an issue, right? So this function is not defined at the point 4, 3. So we're going to need to pick a path in the domain that approaches the point 4, 3. Okay, so the first step is going to be, let's actually sketch what the domain is for this function. So notice the only place I'm going to have an issue is where my denominator is 0. So if we come here and look at the domain, the denominator is going to be 0 when x minus y minus 1 is 0, or when y is equal to x minus 1. Okay, so that's the only place I have an issue, and so on my graph here, let's say this is x, this is y. We'll go ahead and sketch this as this line here. Okay, so that's not in the domain. And then we have the point 4, 3 that we're trying to approach. So this is 4, this is roughly 3, so here's the point that we're trying to approach. We're going to choose any path here. Okay, so I'm actually just going to choose this path. Suppose I'm coming in from the right here. Along the line, we're going to let y equal 3, and we're going to let x approach 4 from the right. Okay, that's just the path I chose. You could choose any path. It doesn't have to be a straight line. It could be a parabola. It could be any kind of crazy curve. Doesn't matter. I just picked this for simplicity. Okay, and so now we're going to actually use this to evaluate the limit. Okay, and I'm going to switch back to white just for ease of being able to see this. So everywhere that I have y in my original function, I'm going to replace it with 3. So I'm still going to have x minus 4 squared here. But now I'm going to have minus, and then 3 minus 3 is just 0, so that's going to go away. Okay, and now in my denominator I'll have x, and then I'm replacing y by 3, so x minus 3 minus 1. Or we can just put that as x minus 4. Okay, and this is now the limit as x approaches 4 from the right. Okay, so the first step of taking these limits is you want to simplify what you have inside here as much as you can before taking the limit. So you can see right away we can cancel one of these factors of x minus 4 in the numerator, and we're going to get the limit as x goes to 4 from the right of x minus 4. And now we can just do direct substitution because x minus 4, that's just a line, it's continuous. And so when we just plug in 4 here, we get that that limit is 0. Okay, and because we know this limit exists, we can choose any path and we will get the same answer, and so this is our final answer.